Today, we have our very first state and local government and education virtual user group meetup. And our presenter today is Jared Pane. He's a solutions architect on Elastic's SLED team. And today he's going to be presenting on keeping services up and running with real-time visibility with Elastic. So again, welcome everybody to today's meetup. Please ask as many questions as you'd like in the chat, and also using the Q&A feature here at the bottom. We'll be monitoring both the chat and the Q&A throughout, so please feel free to ask whatever you'd like in either of those places, and we're happy to answer as we go along. So without further ado, Jared, thanks for being with us today and for presenting.
Yeah, absolutely. Before I get started, can everybody see my screen? I'm gonna guess yes. Cool, perfect. Okay, so yeah, please ask as many questions as possible. The chat's open, Q&A is available. Today I'm gonna talk about keeping your services up and running with real-time visibility in Elastic. So who am I? That is me on the left, not on the right, or vice versa over your screen. I'm Jared Pane. I am the Senior Solutions Architect here at Elastic for the SLED team. I cover the West Coast mostly, but the entire SLED team, hence being a team, we cover the entire United States. So problems, especially in today's world, right? We have too much data and we don't have enough resources, budget, or people. I really want to pay attention to the budget part, but I also don't want to discredit the fact that we have too much data coming in. Especially in these times, the data can get overwhelming, and knowing what services are up, and not only that, but what operations internally to your IT infrastructure is still running is really important. All right, so working from home. It's a reality in today's world, mostly because of the fact that we can't leave our homes. But prior to working from home, you would sometimes have one or two people joining your VPN, maybe joined in your VDI. They logged into your network from a remote place, right? One or two. Well, two turned into three turned into four turned into five. And next thing you know, with what's going on in the world today, we have a lot. This is a really big strain on not only a lot of network people, but operations, administrators. People have a hard time doing their daily jobs as it is in the SLED space. So adding all of these extra people working from home and all of that abundance of data, it's not only hard to keep your services going and running efficiently, effectively, and cost effectively, but also monitoring these things to make sure that they're running properly, right? So with all of this new data, how do you do it in a cost-effective way? So moving forward, operations as we know it today, in this time, they're going to change. It's a known fact. Nothing will ever be the same that we've ever done moving forward. And the reason why I'm seeing a lot of state agencies, at least here in California, are saying we're always afraid of workers being remote, getting into our network, exposing our network, malware, that type of stuff, ransomware, that we were always afraid to extend that remote access to a vast majority of our non-IT workers. Now we just don't have that choice. The choice is that they have to come in. And so I'm noticing a lot of state, local, and higher education IT infrastructure people saying, listen, they have to come in. We don't have a choice. And this is actually not a problem. It's not as big as a problem as what we thought. But they're having a lot of hard times making sure that these people that are coming in, that they're doing it safely, and the security and the operations and the observability of their entire network are still there, right? So recessions happen. I've been super lucky to live through 5 of them. But what we're going to do today is we're going to talk about these last two, the 2002 and 2007. And why these can be predictors of how you can help your operations and your services stay them up and running. Because the employees, the state and local, and the education, the SLED people, the IT infrastructure that keep up and running, that are able to keep their stuff going, they survive this. So the 2002 recession, dot-com bubble, right? It was driven by tech. And I remember specifically sitting at the time I worked for the California Department of Justice. And I was sitting in the director's office with an abundance of soda and donuts, waiting for all of our COBOL programs to explode when it hit the year 2000. And I remember the countdown, and we were all looking at the screen, and next thing you know, nothing happened. But people were still scared, right? So that next year, IT budgets dropped, because now that everything survived, how are we going to keep moving forward with all this? We were so focused on not only the year 2000, but then 9/11 hit, and all these budgets dropped because a lot of this infrastructure went away. So a lot of the successful organizations, at least the state and local agencies, they leveraged open source software for lower cost of ownership. I remember working, like I said, at California Department of Justice, and we were heavily reliant on a large amount of proprietary software. And by the time I had left DOJ and went to another company called Red Hat, who was also an open source, we had gone from our dependence on a full proprietary software to something that was more open source. And that not only freed up budget, but it allowed us to be more agile, and it was more successful in leveraging our solutions and moving forward. So it was a big deal, right? And then some of these companies in the private sector that really thrived were Amazon, eBay, Priceline, Shutterfly. These were really built on open source software, right? Because they were able to keep their systems up and running. So 2007, 2009, right? The Great Recession. Obviously, we all know what happened. We were probably affected by this, right? So it happened because of the mortgage-backed housings. So homeowners paid down their debt instead of borrowing. They lost millions of their homes and savings. Severe contraction of liquidity in global finance markets. Amazon AWS was founded in 2006 in the middle of this, and then built out additional services through the recession and thrived on open source. So this is where it's really important what we mean by keeping your services up and running. The fact is that when the Great Recession hit, budgets were affected extensively. Furloughs, budgets for state and local were almost cut in half. A lot of these older projects that were moving on and on and on, they stopped. There was nothing that they could do about it, right? So what did we learn from these last two recessions that happened? Something that we can all probably remember is that an adoption of open source really accelerated their business, right? Especially in state and local. Open source went from a bad name into something that it was a necessity. And not only that, but it's the same concept of remote work in state, local, and education. People really thought that, hey, look, I'm afraid of remote work. I'm also afraid of open source software. But once this starts migrating forward, they realized that open source was accelerated for a lot of reasons, right? Because there was a large community backing on this. The budgets got tighter. They couldn't really afford the proprietary software. Maybe they were running into data cap limits that they couldn't hit. The thing is that they were able to move forward with that, right? So a lot of the times during these recessions that the hiring freezes came. So you had to be able to do and just complete more with less people. Furloughs hit, potential layoffs, all of this stuff hit from the last two recession. But the thing is that innovation actually increased. And that was really due to being able to keep your stuff running in a cost-effective way. So why open source during the recession, right? More than 50% of the Fortune 500 companies leveraged open source when they supported their mission-critical customer-facing workloads. They liked open source because, like I said earlier, we had a large developer community. People weren't just throwing it over the fence to a terrible support company and saying, hey, look, I need you to help. And the proprietary software, whomever it was that they were using on the back end would say, yeah, we'll eventually get to you. But with open source, you had a community that wanted you to succeed, that wanted you to do stuff. And then not only that, but the lower cost is excessive. Specifically is the fact that you could keep more services running and going with a less retention or less budget. And that's a big deal in SLED, right? And not only that, but decreased time to market. You had innovation on open source. Things went faster. You were able to innovate because of open source. Because open source was innovating faster, you were able to innovate faster internally, like keep your stuff, making sure that you were developing faster, finding things that were wrong with your software and fixing them sooner rather than later. That's a big deal, right? So let's talk about Red Hat. I know I said that I was there earlier, but Red Hat versus the Great Recession. What happened was in 2000, I think it was 2004, 2006, their increase of value was only 14%. But once the recession hit, it jumped from 50 to 60 to 70% year over year growth. And that shows you how many people and how many agencies in the SLED area moved from proprietary software into something that was open source, right? So remember this slide. Moving forward, operations as we know it are going to change, right? So Elastic can help with this. So our recommendation to keeping these services and operations up and running are monitor and collect everything, which we probably already know. Today, after this slide deck, what I'm going to show you is how we recommend monitoring and collecting these data. Things that I'm seeing out in the real world when I go visit the people that are using Elastic from day to day. People that say, thank you for allowing me to keep my stuff up and running without having to pay an exorbitant cost down the road or year over year. And because of our community and because of who we are as Elastic, we want to talk together and keep our stuff going as a whole, right? So 3 solutions, which I'm going to talk about today on how it's essential to keep stuff going, is observability and security. Elastic in general is built on 3 solutions: enterprise search, observability, and security. But like I said, we're going to talk about the center and the right column. I'm going to show you how this is going to happen today. So observability, this is one of the biggest things that we can do to keep our stuff going, right? Logging. If you have like over 1,000 servers, 5,000 servers, 10,000 servers, the last thing that you want to do is log in to an actual server and try to monitor that server.log file by just tailing -fing over and over again. It's just never going to work. It's not sustainable. You have 1,000 servers, you're monitoring one. What are you going to do? Have 1,000 tabs open? It's almost impossible. In fact, it is impossible. I've done it. So that's a big deal to make sure that your stuff is going properly by using and having an ability to use something that shows you all of your logs or all of your servers in one pane of glass, right? Metrics. Is your CPU properly formatted? Is your CPU using 80% utilization? And for how long is it doing that for? How's my storage looking? What about my JVM? What about my RAM? What about application performance monitoring, right? Everything in application performance monitoring, is something going wrong? Can I follow that trace across multiple development languages? Java, Python, .NET, microservices? What is happening here, right? And then also uptime for observability. Is my stuff actually running? And you can kind of draw a circle around all those and say, hey, look, I have all of these going, but how do I know if something goes down? So I want to throw in alerting on top of that too as well. So first things first, when I talk about observability and I talk about security, everything that I'm going to show you here today, it's all going to be in our basic license. So you can get this up and running and started today. So you can download this stuff, install it, get up and running, start visualizing it right out of the box in less than 5 minutes. There's no cost, it's free, and it's open. And I think that's the way a lot of this software should be, right? So keeping your services going, you could do it right after you get off of this meetup. Right? So observability, I'm not gonna read that top part about it, right? But it really translates to a combination of critical components and being able to see those components and being able to make sure that your stuff is going. A lot of us work in critical areas. I think that state, local, and even higher education is exceptionally critical when it comes to keeping your stuff up, right? So monitoring, alerting, and then distributed tracing, logging aggregations, and your analytics, right? So why is observability important? Because more and more systems have become exponentially complex, right? So when we first started, You developed on a mainframe, right? I'm going to raise my hand. I developed on a COBOL 74 machine. That was great. It was the best times of my life, I promise you. But then as things started moving forward, you move from COBOL to SQL to like Java, and then you go from a log file that was 10 kilobytes to 2 log files that were 10 kilobytes to 50 log files that were 10 megabytes, and then 50 to 100, 100 to 1,000. Next thing you know, you're looking at gigabytes to terabytes of logs. You need to be able to take a look at that. Not only that, from a Java perspective, you went from like a COBOL to a SQL to a Java to a Golang to a Python. And the next thing you know, you need to be able to visualize how these applications or transactions or these services are going through each one of those application layers. Right? Microservices came into existence. Containers came into existence. Kubernetes, which is the hot item right now and has been for the past couple of years. All of these things add complexity to what you're doing. How do you know if one of your pods go down in a Kubernetes environment? Maybe you don't. How do I know if my application is returning an SLA that I need specific from a law that says you have to respond within a certain second? You don't know unless you're testing it over and over again, right? So I guess observability goes past the reason of what went wrong to why did this go wrong, and that helps not only in the long term, but it helps keep your stuff going today, right? I remember sitting in a big, I guess like conference room, and you would have your server admin team on the line, and then you have your network team on the line, you have your developer team on the line, and then you'd have all the managers on the line, and everybody wants to know what's going on, and each individual team has to talk to each individual team to make sure that everybody is on the same page as to why my services is not running anymore. And I think the most frustrating part about that is that we just didn't have the visibility into everything into one single pane of glass, right? So it really delivers just being able to view this stuff. It kind of gives you that single connected view of everything in one place and in real time, right? And so this is what, when I show you the demo today, or at least when I show you how I'm taking care of my visibility, you're going to see this across your entire network. It's just super easy to use, and you don't have to actually leave Elasticsearch. The last thing that I want to talk about, and why this is very important in keeping your stuff up and running, is Elastic security, right? So what's happening is that we're really forced to be more and more digitized. I know I've talked about working from home. The news is talking about working from home, but we're really doing it more and more. I know my oldest daughter is jumping on Zoom 2 to 3 times a day, not only to deal with her schoolwork, but also to deal with her friends, right? My network bandwidth has increased extensively, and I'm sure that the state and local and the education space has actually increased extensively. So it's one of those things where like this situation is probably not going to be temporary, and we need to be able to onboard these people into our infrastructure and onto these networks without having to worry about like data exfiltration or ransomware or malware or getting into things that these people are not allowed to be into, right? Or how do we know if these people's computers at home are secure? We don't. And this is all about something of somebody coming in who has a malware or ransomware, and they get internal to your network and it just starts spreading. And now you're out of business because you're down. And the person down the street who needs to register their car or needs to register for a class or needs to be able to do something from a public service perspective can't get into it because now your stuff is out of order. So what's happening is that these forced challenges need to be able to be mitigated and stopped. And Elasticsearch, especially in the security space, it's always going to be free and it's always going to be open. And I love the fact that we really make sure that we let people know that they can use us and they can use our SIM and they can do it for free without actually having to worry about paying somebody to make sure that their stuff is not only still running, but not down, but also secure. So that's a really big deal, right? So all these solutions, they're powered by one stack. I'm going to apologize if you are aware of how the stack works. I'm just going to go super high level. Kibana is your UI. Elasticsearch is your storage area. Beats and Logstash, those are your ingestion tools into Elastic. So, right. So I'm going to show you how to get started with Elastic super fast. And then I'm going to show you how to observe all of your data and all of your components internally to Elastic. And the first thing I want to show you or explain to you is Beats. So I'm using Beats on my system. So I have my internal network at home all monitored, up and running. And I'm going to show you how easy it is to actually get the stuff going. I know a lot of times that you can't be monitoring anything and everything in your IT infrastructure. I mean, maybe you are. I'm sure you're dropping some things on the floor. And maybe it's because you've hit your data limits on some other software that you're already using for monitoring or observing things. But I'm here to let you know and talk about the fact that we can do all this stuff free and right after we get off of this meetup. And one of the things that'll help you is Beats. So Beats are super lightweight data shippers. They're written in Golang. And what they do is they ship data from an appliance or workstation or an endpoint, whatever it is that you're doing, into Elastic. We have generated modules that are already pre-created. You set those up, you enable them based upon what type of data that you want to ingest. And then we build out those dashboards for you. A specific example would be, let's say you want to grab your system data from your workstation or your virtual machine or your VDI machine. All you have to do is just install a metric beat, set up the dashboards by just running a metric beat setup, and I'll show you. And it builds out those dashboards for you automatically, Kibana. So the whole idea is that you can go from data to dashboards in less than 5 minutes. You can start visualizing that data from where these people are coming in and what they're doing, and you can make sure that your VMs are up and running and they're still ready to go. So I'll show you the beats that we do support and the beats I'm going to be working with today. But just in case we don't have something that you can't use or that we don't support, we have over 70 plus community beats. Not only that, but we now have a way to build your own beats module internally. So if you're an agency that I think it's called Brew Beats, what we do is let's say you're an agency that you need a specific beat for a specific homegrown system that you want. Because we are open source, we allow you to build out a module specifically for a specific beat so that you can start ingesting that data without having to rely on us to give that to you. But that's the reason why open source is so important, because of the fact that if we don't give it to you, maybe the community has done something. A story is I was working with an agency here in California, and they wanted to do something. They wanted a beat for PHP. Well, we didn't have one at the time. And so they went to the community, they found a PHP beat, and they made 2 little line adjustments for their environment. And next thing you know, they had everything up and running, and they were ingesting PHP stuff into APM data. So it's the fact that it's super quick to get going. And if we don't have it, the community probably does, right? So these are the things, these are the beats that we have at Elastic. And then I'm going to show you the ones that we are going to be using. Heartbeat is definitely one of the things that is super important, especially if you're trying to keep your services up and running. You need to know if your stuff is up or if it's down. And that's one of those things where it can not only do a virtual machine. I have it on all my Nest equipment in my house. I have it on my front doorbell. I have it on my Apple TVs. So I want to know what is going on my internal network in my home, and are these things up and running? And when one goes down, I automatically get an alert from it. Metric beat, it grabs all your metrics, everything that you need to know: CPU, storage, JVM, garbage collection, that type of stuff. Packet beat, network data. This goes hand in hand with, let's say you want to know what is going on in your network, TCP, HTTP, ICMP, DNS, doesn't matter. The whole idea is that you're grabbing that data and you're taking a look at it from a network view. I have Packet Beat going here. I'm going to show you how I'm actually keeping my stuff running internally in my house by visualizing my network data. And by the way, when I show you how I did all of this, I didn't build a single thing. I installed and I started ingesting data, and everything was taken care of it for me. And the last thing I want to show you is Audit Beat. Audit Beat is the way to monitor your audit data, your system D data, everything that's going on in your Linux machine. If you want to do the opposite from a Windows stuff, you want to use winlogbeat in the upper right-hand corner. That can even you can even do sysmon information with winlogbeat as well. So this is how the Elastic components work together, at least from the point of view of my my environment. And you could do this environment too in your agency, right? So Beats, Elasticsearch into Kibana. Now, the caveat is that everything is going to be mapped to the ECS. ECS stands for the Elastic Common Schema. So Beats maps everything to the ECS automatically, like right out of the gate. If you want to enrich this data, you can throw in Logstash in between Beats and Elasticsearch, and you can add like GeoIP information, or you can use one of our mini filters, a graph pattern. You can dissect your data that's coming in and out. The whole idea is that you could do whatever it is that you want with any type of data, and you have unlimited ingestion options. We don't cap you. We allow you to do and ingest as much as you want. But this is kind of the infrastructure that I did today. It's super easy. And like I've said before, you can get going on this right after the meetup. So I'm going to go ahead and show you what I'm doing and how I made this work. I'm going to go over the question here. There's a question here. Going to be made available next Tuesday. Okay, cool. So first things first, let's jump on over to here. I'm going to kind of give you an idea of what I'm running and why it's easy and how you can do this and why it's easy for me to keep my services going here at home. So I have an Elasticsearch instance running on my laptop. All I did is I just went to elastic.co and I went to download Elasticsearch, and we downloaded that. And then I unzipped it and I started it up. That was it. Next thing we have is Kibana. Kibana is running right now, and it's actually doing really well. All I did is I downloaded Kibana, and I'm going to show you the one change that I made to the Kibana config. All I did is I added my super unique and super secure password down here. So it's my username and password. That's all I did in my Kibana config, right? And then I have, this is metric beat. I'm gonna stop this real quick. And I have audit beat going here. So it's monitoring all my audit data internally to my MacBook. Like I said, you can have this on any type of Linux machine at any point you want. And then I also have a packet beat going. So this is monitoring all of my network data going across the wire. So what I want to do is I want to show you how easy it is to get metric beat up and running on the system. So I downloaded metric beat, and I'm going to forward this to my Elasticsearch server, and then I'm going to visualize it with Kibana. And this is going to allow me to see everything that I have running or what my actual metrics are on my MacBook here. So the first things first is all I have to do is go into metricbeat.yaml file, and let's see here. Cool, I split the screen. So anyway, I'm gonna go into my metricbeat.yaml file, and I'm gonna go down to my output here. And you can see I've added my host, and then I've added my super secret username and password. And then after I added my username and password, I'm just pointing it to Elasticsearch, and I'm going to start up metric beat. It's just a -E. If you want to set up your dashboards, I've already done that. You just run metric beat and then setup. But here you're just going to run metric beat -E, and then it's going to be grabbing your information and running that. So as this is going, I'm going to bump over here to my overview, and I'm going to take a look at everything that's going on here in in Kibana. So the first things first, I'm going to go into my infrastructure view, and my infrastructure view is picked up my MacBook already. If I click on my MacBook, I can take a look at the logs, I can use the metrics, and I can view my host APM traces if I had any. What I want to do is I want to take a look at my metrics. The more hosts that you have, I'm going to go back to this really quick. The more hosts that you have on this, so if you have your entire infrastructure going on, you're going to be able to see each one of your servers, or each one of your machines, workstations, physical servers, whatever it is that you are monitoring from an infrastructure perspective. These are going to be broken down in a quote waffle type zone, right? You can even go down to the Kubernetes and or Docker layer to monitor the CPU, the traffic coming in and out, and or the JVM or the garbage collection that's coming in. So right now, this is from the past hour. And there should be, you'll see a little gap in here from the data that I stopped it. But you'll see that my CPU and everything is going on. You'll see the load from everything that I'm having internally in my PC. You're taking a look at the memory usage. And then you'll also see the actual network traffic. So as you can see here, I wasn't doing much work this morning. And then all of a sudden at 11:55, that shut up because I was in this meeting. My network traffic is going extensive. So that is one way to make sure that your stuff is up and running. So the question is, how is this metric beat going to help me monitor, let's say, a server? Or how is metric beat going to help me monitor my Docker or my Kubernetes install? So what you could do is you could easily build up a dashboard, or you could use the dashboard that comes right off the right out of the box with metric beat. So I'm going to look for metric beat, and I want metric beat system. Let's do metric beat system. So I'm going to look at my overview, and everything's in Elastic Common Schema. And you'll see over the last 15 minutes, let's break this down to last hour. You'll see the last hour, my disk usage, my top hosts. So if you had multiple hosts here, you will see these broken down. You'll see the inbound, outbound traffic, and then the number of hosts that are actually responding. And then you can just see everything as it's going on, the host histogram by CPU usage. And obviously my CPU usage is getting pretty high over here. So that could be a problem. So what I want to do is say, hey, look, I don't think this is right. Anytime my CPU gets really high, I want to alert on that. So what we do is we can go into management and we can grab a watcher alert. Watcher is our alerting. So we want to create an alert threshold. So I'm going to go CPU threshold, and I want to do metric beat, and I'm going to select the timestamp field. I'm going to run this every minute. So I'm going to go when count, I want a max of, let's see here, let's go CPU, actually it's system, CPU, total norm percentage over all documents is above, because we're dealing with percentages here, percentage over 25% over a period of time, add an action. I have not set up my email. So I can have it added to a log. I can send myself a Slack message. I can add an index data into Elasticsearch. I can do a PagerDuty. And in the worst case, I could do a webhook. So if I want to send this to like ServiceNow or something at that point. So now I can get an alert if my CPU is higher. You don't have to stop there. You can get alerts on anything, right? Is my SLA taking too long? Is my JVM getting too high? Is my garbage collection at a certain percentage over a period of time? Is my network throughput slowing down, or is it speeding up? That is the type of alerting that you could do. And if you want to get crazy, you can create an advanced alert by using some JSON, right? So what I'm going to do is I'm going to go back into here, and I'm going to show you how not only keeping my my metrics available, but what my network is doing. So in my network here, I'm going to see all of my DNS transactions. This is just PacketBeat, by the way. I've just installed PacketBeat. I started it. I got it up and running, and it's managing all my TLS sessions, my HTTP transactions, my DNS types. You can see my response times for everything on the network. You can see the percentiles of the OKs, and then every single time that there's an error that's being handled. You can see the response times over the percentage. You can see errors over ICMP, DNS, or TLS, right? And you can see the latency histogram. So if you want to check on the performance of your network as you're going down, you can actually do this and take a look at this. Now, granted, I have not done anything. I've said this before. I have not made any changes. I've not built any visualizations. These are straight out of the box, right? You can also take a look at like network flows. I want to see specifically all of my network flow patterns across my entire network. You absolutely can. You can see your unique flows. You can see the top hosts that are receiving PacketBeat traffic. I'm guessing this is probably Zoom at some point, right? And then you can also see like the hosts that are creating traffic the most. You can see every source IP, every destination IP, anything that's going on here. You can build this, build these dashboards and take a look at it, right? And the last thing I want to take a look at is the HTTP transactions, right? You can see if your network is up and running. Obviously, I don't have any going on here, but the whole idea is that you could see the stuff that's happening and how this works. Okay, let's take a break here. Okay, cool. So next thing what I'm going to do is I'm going to show you a really easy way to actually keep not only visibility in your services, but making sure that they're not down prior to actually being down, right? So you can actually be proactive rather than reactive. So what you could do is you could build easily a dashboard that looks like this, that contains all of your logs, all of your metrics, all of your APM data, and then you could do a cross coordination of this, of like all of your services that come across from your actual application, and then cross correlate those directly into your CPUs, your max memory, and everything else that's going on. So you can make sure that not only is your system running properly, but it's coexisting with everything else that's going along in your actual environment, right? So that's a big deal. The next thing that we could do is, let's see here. Oh, I want to show you uptime. So I know we talked about uptime, but this is a big deal, especially when you're dealing with your services. Like, is my application up and running? Is my machine up and running? Like, where is it going? What's happening? So right now I have 23 services up. One of these services is down. You could check the URL on each one of these, right? You can see if these things are being pinged properly. So elastic.co is up, which is a good thing. You could see each one of these services. You could take a look at where they are, location names. So you could say, hey, look, I want to add a location to this. And it'll bring you right to the actual documentation on how to add metadata to this, so that when you come into this, you'll actually be able to see a listing of where this is on your network or inside your IT environment. The whole idea is that the cost of downtime starts getting eliminated because you don't have to waste your time going through and trying to figure out what's wrong. It has that unified look to where you can go ahead and grab that. The next thing I want to show you too is our logging. Remember when I said that we used to do, let's say you have like 1,000 logs coming in. What do you want to do? Just tail -F every single one of those? It's probably almost impossible. The best part here about our logging system is that everything is going to come into one single pane of glass. And so if I want to know anytime that there's an error that comes through, all I have to do is highlight the errors, and it's going to show me each single time as these logs are rolling in where the errors are coming from and what's going on. I should probably take a look at my Redis, because obviously it can't access my storage cart. So the whole idea is that now that I know there's a problem, I should probably go look at it. Case in point. So the whole idea is that you can get your stuff going without even having to do stuff. So let's take a look at your APM. Application performance monitoring, right? You can monitor all of your stuff all the way down to a microservices layer. Microservices can be a little tricky, and especially when you're running and using multiple application software, Java, Python, MySQL. And so what you're doing is we're allowing you to bring everything together. And so as you're monitoring your applications, you can see all of this in one unified format. So you can see the time spent by span here on each of these transactions, right? You can see the transaction duration. So if you want to make sure that your SLA is running, your end user, your actual, the public entity that is trying to use your service as a agency is up and running, is giving the requests that need to, you can view them here in a simple, easy, just super simple, easy dashboard, right? Then you can also take a look at your requests per minutes. Now, if you want to start digging down even deeper and start getting into transactions, you absolutely can. So if you want to click on Get Ads here, you could see that, hey, look, this is my service, this is my transaction, right? Your transaction duration, your request per minutes, and you can see how each one is. So we have 108,251 requests here with a transaction of close to 0 milliseconds. And then if you're looking over there, you have one request that is taking 8,500 and 9,000 milliseconds. You could dig into that transaction and see exactly what's going on, right? So you can see the full stack trace. You can take a look at each actions. You can go into the container of that log that's containing that. You can grab the host data. You can even grab the trace data. You could show the pod metrics. So the whole idea is you never actually have to leave Kibana. You could stay internal, and then you could just move and pop around, right? So you can look at the metadata in case you want to know what's going on, the labels, the transactions ID. And then obviously there's an error here. So if we want to take a look at this transaction and see where this error is coming from, I could start digging down. I'm pretty sure it's going to be from my Redis environment. that is actually causing me, that showed me that error and that log that I was getting. So with that said, we have about 18 minutes left. What I wanted to do is open it up to some questions or anything that I can help answer. And I'll present this too. The last thing is that we have a lot of free resources here at Elastic. We're giving away free training. So the training, the Learn from Home, please go to that first link. We'll make sure that everybody has these links too. That way you can take Elastic for free, get the training, do whatever you need. I don't think I need to say this, but I want to make sure I do. If anybody has any questions, my email address is right here, jared.pane@elastic.co. So two things. One, if you want an invite to the public sector Elastic Stack community, it is private. We will invite you. Just shoot me over an email and say, hey, I'd really like to be invited to the public sector Elastic Stack community. I will send you out an invite, not a problem. And then we just have a general public Elastic Stack community. You can go ahead and visit that as well. It's elasticstack.slack.com. And then the next thing I want to do is what we're trying to do in these virtual meetups is do one almost every month and a half, I think is that we're trying to do. And our next virtual meetup is going to be led by Ruben. Ruben is my counterpart. He's also a solutions architect. He's in the East. And he is going to be talking about seamless monitoring and integrated threat hunting with Elastic APM. So he's going to do a deeper dive into threat hunting with Elastic APM, which is pretty cool. So I'm going to leave this up on the screen, so feel free to take a screenshot of it. I think we're going to be making sure that the slide deck gets available after the meetup too as well. But while this is up and running, I can answer any questions. If everybody has anything that they'd like to discuss, or if anybody wants to talk about anything, please, let me know.
I'm not seeing any questions in the chat except for some requests for the slide and the recording. The recording will be made available probably by midweek next week, and we can send that out to you guys. It'll also be on the event page.
Awesome.
Somebody has asked if you can show machine learning.
I can absolutely show machine learning. The one caveat is that it is not on, yeah, hold on a second. Stop sharing, why is this? Yeah, so what we're gonna do is we're gonna talk about machine learning in future webinars. I don't know why my screen, there we go. But I think I don't have anything up and running right now for machine learning, but I can absolutely do that. I think the best thing would be to wait for future webinars to see the machine learning, how it integrates directly into Elasticsearch, if that's okay. So let me see if I can just show, please hold, I'm gonna grab something real quick so I can just at least give you an overview of machine learning. 1 second, all right. Cool, and share. Okay, can you see my screen?
Yes.
All right, great. Let's go in here. Okay, what I'm gonna do is I'm gonna show you super quick some machine learning stuff. And like I said, in future meetups, we'll definitely be talking about machine learning. But right now, I'll just do a super quick overview and then show you how each one of these are integrated. So what you're looking at right now is our Elastic SIM. And our Elastic SIM is 100% free. Machine learning is in our Platinum license. So you will not be able to use that out of the box. But I believe, as Ruben said in the chat, you absolutely can leverage our trial license and test that out. So all you would need to do is download Elastic, or you can go to cloud.elastic.co, and I'll show you how to do that too as well. You can go into cloud.elastic.co, and all you have to do is sign up. You don't need a credit card. All you do is just put in your email address, and then you are up and running, and then you have full access to all machine learning and everything. Worst case scenario, how you do it in let's say you have an install locally, what you would do is you would go into management here, and right in you'll see a manage license management, And you would have two options. You would have start your trial and then update your license. And you would want to start your trial. And what you would do is you get all of these features. So with that said, machine learning. So our sim is actually, like I said, open and free. But out of the box, you will go ahead and get 14 machine learning jobs right out of the box. I think it's 18 now. Maybe it's 24. I think so. Anyway, the point is this: between 15 and 30, you're going to get machine learning jobs like right out of the box. And the whole idea is that you don't have to build those. You can just get up and running with the data that you have right now. And then not only that, but these machine learning jobs, they connect directly into our SIM. So let's take a look at this one, like Linux anomalous network activity on Elastic Common Schema. Before we dig a little bit into this, just a really super quick high level overview of machine learning. Machine learning is it's unsupervised machine learning. So what does unsupervised machine learning mean? Is that you don't have to actually program anything to get going, right? You could just go up, you could just start up and running, create your job, tell it what actual fields you want to go ahead and start learning on. And then as the more data that comes in, the machine learning actually learns all by itself without me having to tell it what to do. And why that's important is because it really cuts down on false positives, especially from a security perspective. You can get a lot of false positive fatigue. And so what machine learning does is it actually takes a look at that data and says like, yeah, this is really something that is wrong. And this is a problem, and you should probably look at this. So let's take a look at, I got to find one that is running. Let's do these. Let's see what's going on here. So, okay. Yeah. So this is machine learning. And what we're doing here is we're taking a look at some of the top influencers by host name. And then we're cross-referencing those with agent type and the DNS questions, right? So blank means there's nothing going on. Blue means that you have a lower anomaly score. Yellow means it's pretty higher. If you had an orange would be between like 50 and 75. And then red is probably, well, actually it's not probably, it's, hey, look, we have an anomaly score here. It's very high. We need to take a look at this, like what's going on. You can alert on everything that you have internally to machine learning. And so what happens is that you get an anomaly that comes in and you get a really high severity score. You can tell this anomaly to do something, or you could take a look and dig deeper into this anomaly by actions, right? So what we're going to do is you can see this anomaly right here, and you can see that it's got a critical anomaly count by ML category for mid category 1. This is mapped back to the MITRE ATT&CK framework. The actual is the actual is 282, and the typical is 359, right? So it's telling you what's going on, and then you could actually take a look at some of these category examples too as well. So this is looking at credential dumping. So we're seeing that a lot of these people, or this one right here is a big problem. So we can take a look at, let's see, view this example, and each one of these is attached to something else. So if you want it to click on an action to bring us directly into a SIM, or to bring in directly into this Discover, you absolutely can. So right now, we don't have any in the last 24 hours. Unfortunately, I don't know when this was built. So this will be the last year. Yeah, so we obviously don't have any data on this right now. But the whole idea is that the machine learning is super simple to get up and running, and to actually build that data once it's in, it starts learning on it. And I'll show you how to build an actual job really quick. And it is super simple. Oh, it's telling me that I can only view one job at a time. So let's create a new job. And what I want to do is I want to search the index pattern or the result that I want to do. So let's just do endgame for this. Endgame is our endpoint protection. We could do a single metric. We will always want to use the full endgame data. And please be patient with me. I don't know what's in this data right now. So we go next, and then we pick a field, right? So we could do a high count. Is there a high count of something? Is there a low count of something? Are we doing an average of stuff? The mean, the high mean, the low size. So we could do high mean, right? And then we can do, let's see, actually let's do, I gotta find some, there we go. Let's do the count, right? And then estimate bucket span, 5 minutes. Okay, let's do 15 then. And we go next. Job ID. Groups, let's call this, group this as, how about sim? Okay. And then we could do advanced settings. So we can actually enable the model memory limit, enable the model time, and then we could add additional settings on top of that too as well. So we can add custom URLs. So if you want this to point back to, I don't know, like, how about, let's go view dashboard, and we add this. And then there it is. We click, see, test the URL, make sure it works. As it's loaded, we're gonna go down here. Okay, options. Then we click next. And then as this is going, what it's gonna do is you can go ahead and create your job, and it's running the result. So it's actually learning your data as it's going down. And then at the end of this, you'll be able to view the results as it's learning your data and it's grabbing it. And you'll be able to see it in a time series event, and you'll be able to see the actual anomalies as it's building. So here's an anomaly score 56, right? And here's what a 58. And the more data that you give it, you can move the timeline over. So as you can see on the left-hand side, right, it didn't know what much of our data was. And as the more and more data you gave it, the tighter and tighter it got, and was able to actually find the anomalies in your actual data. So remember that dashboard that we created that said like, hey, if it does something, I want you to go ahead and do something with that. You can go ahead and select view dashboard, and it'll bring you to this dashboard here. And this is the sample logs data. Obviously we don't have anything here. It was just a super quick build out of something. But you could, if you had data in here, you absolutely can grab data and take a look at anything that's going on here. So yeah, so we have data here, but it just needed to be over the last 90 days. So as you can take a look at this log data, you can see who's coming in, a type scatter plot, right? Your heat map of what's going on, your source and destination SAN key, and here's just one of our mapping, geo-IP mapping sections of it too as well. So hopefully that helped. Really super quick, high level overview of machine learning. But it's really super simple to get up and running. Like I said, I just created a job on the fly, but we have up to 25 or 30 machine learning jobs just right out of the box, ready for you to go. Yeah, no problem. Any more questions?
I don't think so.
Okay.
Thank you so much, Jared, for walking us all through all of this today. It was super, super interesting, super helpful. I will send a follow-up email. We'll send a follow-up email out to folks who attended with a recording. And we hope to see you at our next event, which will be at the end of May 28th. All right. Well, thanks again, Jared. And we hope to see everybody next month.
Everybody, thank you so much, and have a great rest of the week.